segment we will be discussing about how to design a topology using IP addressing, subnetting and all. So here you need to design this following topology given by this network. This is the original class C network, 192.168.0.0 network, and here the requirement is that the connectivity among these routers are as given in the picture, and R1 should be connected with LAN 1, which required 50 PC, R2 in LAN 2, which required 30 PC, R3 in LAN 3, which required 10 PCs, R4 in LAN 4, which required 20 PC, and R5 in LAN 5, which required 6 PCs. Now let's understand that how we create this subnetting, how we go for further subnetting of subnetwork and all those things. So with this example, let's understand this. So here I am giving a specification that R1 required the requirement of R1 is R1 need to be connected with 50 PC. So the requirement is 50 PC should have 50 IP. Now there is something called the concept of gateway. What is gateway? Gateway is by which the PCs in the LAN 1 will be connected to other networks. So that's nothing but the IP given to the router. So one IP should be allotted to the router. So the requirement is now 51 host. So that's whenever we are collecting number of IPs, we have to collect the number of PCs as well as number of gateways. So 51 host. Now we will be using this particular formula, 2 to the power n, which is greater than equal to 50. So that 2 to the power n, okay, the power of n is actually block size. So 2 to the power n we have to calculate. So 2 to the power when 2 power of power will be 6, 2 to the power of 6, power of 6, this results me 64. So if 2 to the power n greater than equal to 51, it has to be 64. It cannot be less. If it is 32, then we cannot take. So here in this case I have to calculate the block size. So here in this case the block size is actually 64. Now initially I have been given a network 192.168.0.0. so here when the block size is 64, that means that's 2 to the power 6. That means here I have to calculate, I have calculated host bit as 6. When I have calculated host bit as 6, so my network bit will be 32 minus 6 is 26. This is my calculation of network bit. Now here in this case we have seen host bit is 6, so network bit is 26. So initially it was /24. Now it becomes /26. So when it becomes /26, we can create how many subnetworks? Because in that 8-bit block, 6-bit is now in host bit, so 2-bit we have borrowed. So since we have borrowed 2-bit, 2 to the power 2 is 4, so 4 number of subnetworks we can create. So let's understand what are those. So 172. So to do this calculation, let me go to a calculator and do the same. So for example, this is my calculator. Here I am taking all this bitwise calculation. This is, for example, network 192.168.0.0. Now here this 2-bit I have borrowed, so this 2-bit since I have borrowed, so I will be getting all possible combination of these two, that is 192.168.0.0. so next possible combination is 01, that is 64, 10, 128 and 01. So 11, that is 192. So how many subnetworks I can create? 192 dot, from this, if I am borrowing 2-bit, okay, after borrowing 2 bits, I can create 4 subnetworks. This is the first one. Now next is 64, next is 128, and last one is 192. So here in all those cases, the subnet mask will be 255.255.255.192. Why this will be subnet mask? Because my host bit is 6, so 26 it actually now network bit. So calculating network bit, this 26 bit, so this in this calculation, this all bit will be 1, and here it is all bit will be 0. So that is how we calculate the subnet mask. So in these 4 subnetworks, I will be only taking the first subnetworks. So let's get the specification. This will be my network address. This will be my network address. This will be my broadcast address. And excluding this two, I will be getting, this is my first IP, first valid IP I am getting, and this is my last IP. So this is my first IP and this is my last IP. So that is what my calculation is. So now out of this 256 block, I have used 0 to 63. So next block is this 192.168.0.24. Now I'm going for the calculation of the second router, that is in here the router 2 is connected with 30 PC. Now we have to give the priority, as per as the size of the subnetwork. Now the size of the subnetwork, 50 PC means 51 host, then 30 PC means 31 host. Now here in this case, there is a 30 PC, so it will be 31 host. Now if it is 31 host, then in this case the block size cannot be 32, because 32 minus 2 is 30 host, but here in this case I require 31 host. So here in this case block size will be 64. So since this is for router 2, since the block size is 34, so I have to go for the next subnetwork, which is 64. The first IP will be 65, that I will be always giving it to the router. Now last IP will be 126, because 127 is broadcast IP. So that is my subnet mask all about. Again, in this case the subnet mask will be the calculation, it's 26 bits is there in the network, host bit is 6, so since network bit is 26, this is how we have calculated, since network bit is 26. From host bit we have calculated, so initially from the requirement we have calculated, since block size is 64, so we have calculated all those things as a host bit as 6 and network bit as 26, and in this case we have borrowed again the same way we need to go for borrowing all those things, borrowing the bits. So here you can see 64 is network address, 65 is first IP, 126 is last IP, 127 broadcast address. This is my subnet mask, and subnet mask is calculating all 26 bit to 1 and host all bit to be 0. So that is how I have calculated. So going for the next one, that is now not router 3, going for the next one, that is router 4, because whenever we will be creating subnet we have to give priority to the bigger blocks. So let's go for R4. R4 is 20 PC, so 20 PC is 20 plus 1 21. Then here in this case we have to go for block size of 32, host bit will be 5, so this will be 27. So here in this case what you can see, we have already used 0.0, 0.64. so this is my next subnetworks. So the concept is, when I have next subnetwork, so this subnetwork again I am going for, instead of /26 I am going for /27. That means one more bit I am borrowing. So when I am borrowing one more bit, that means this is the concept, we go for subnetwork of subnetwork. Means initially we have 4 subnetworks. Here in this case, when I was actually taking the bigger blocks, I had a 4 subnetworks. When I had 4 subnetworks, I have used 2 subnetworks. Now from this third subnetworks, if I am borrowing one more bits, then I am actually creating from this /128, I am actually creating 2 more subnetworks. So let's understand how I am creating these 2 more subnetworks. From this calculator, we can actually calculate. So here in this case I am borrowing one more bit. So since I am borrowing one more bit here, if this bit is fixed, so I am calculating 2 subnetworks, that is 100 and 101. Are you getting it? What is the concept? Initially this 2 bit was utilized. Now when this 1 bit is borrowed, so in this case this was the bigger network, so this bit I have borrowed, so 128 network is further subdivided, because this bit I can actually, this bit can set to 0, set to 1, so I will be getting 100 and 101. So 2 sub networks I am getting. Okay, so in case of /27, actually I am going for 2 sub networks. This will help you to calculate better. This is 2 sub networks I have created. So this next sub network I will not use. The next sub networks will be used for the next calculation. So this I have done. So this sub networks I have /20 dots 28/26. When I am borrowing one more bit, further subdivided. Okay, so since it is further subdivided, so that means this bigger sub networks is again split into, after borrowing one more bit, further subdivided into 2 to the power 1, that is 2 sub networks. So 2 sub networks are .128/27 and .160.27. So that is how we can also calculate. So when I have calculated this, let's calculate this particular subnetwork in terms of calculating network address, in terms of calculating first IP, in terms of calculating broadcast address, and this will be all /27. So since this is all /27, I will be getting, this is how I will be calculating my subnet mask, because network bit is 27, host bit is 5, and sorry, this is 128, this will be 129, and this will be 158. So this is what my first IP, last IP, and all and all those things. Now next is 10 PC. So this I have created the third subnetwork. Now after creating the third subnetwork, I am going for router 3 10 PC, router 3 10 PC. Now router 3, when I am having 10 PC, I am having 11 hosts, so there will be block size of 16. Okay, when there is a block size of 16, so this is 4 bit. So since this is 4 bit, this is /28. So instead of using this one, I'll be using /20. This is again subnetwork of subnetwork. So here in this case we can calculate, this is /28. So since /28, this will be till the next one will be 176/28. So again I am further subdividing and further subnetting I am doing. So /176 is the next one. So this is 175. The last IP will be 174. So this is 160 is the network, 161. So this is /28, this is /28, this is /28, this is also /28, and this will be 240. So this is my calculation. Block size of 16 in this case. For R3 I have calculated, this is my network address, this is my first IP, last IP, first IP to be given to the router, last IP 174, broadcast address 175. Then I am going for router 5. In router 5, when I am going for calculating router 5, it required 6 PC. So 6 PC plus 1, 7. So 7 plus 2, 9. So we have to go for this one, this particular subnetworks. So my here in this case my block size will be 16, so it will start from 76, and this 76 will go till 192. So till 192. So till 192, this is 176 till 191 it will be. So this is my subnetwork. So my first IP will be, this is my network address, my first IP, last IP, broadcast address, and this is my subnet mask. So next we have 1 2 3 4 5 6 different networks. So 6 different network will be all of size 4. So since host bit is, since there is in between router there is a connectivity of 4 to 2 IP, so I will be requiring block size of 4. So here in this case, if I am going for block size of 4, it will be /30. So from /192 I will be getting all 30 network. So here I am getting only two IP addresses, that is 192, first IP is 193, last IP is 194, broadcast address is 195. So this is /30. So I am calculating all those different sub networks in this case. So it is 30, it is host bit 2, so it is my block size 4, host bit 2, network bit 30. So this is my specification. 3 and 4, 2 IP I am getting. So this will be 252. Sorry, I've calculated. Okay, so this is my subnet mask. So this is one network. Next will be, after 192 add 4, 196. So next network will be 196, 197, 198, 199. So this is my next network. Next network will be again 200, 201, then 200, then next 201, then it will be 202, then it will be 203, like that. Next network will be 204, so it will be 204. First IP will be 205, 206 will be last IP, this is 207, next will be 208, like that. You have to go for the calculations. So many subnetworks we can create now, and this is the calculations. We can create after 208, it will be 212, then it will be 216, 220, it will be continuing like that. So you have to keep on calculating all this. This is for 204, so then you have to calculate for 208 and all those things. So let's see how many subnetworks I have created. 192 network, 196 network, 200, 204, 208, 212. So that's, I am allotting each and every IP to the router. So router 1, router 2, router 3, router 4, router 5, and I am making the connectivity as per as this specification, fast Ethernet and serial interface, and these are the IPs for different router interfaces. Okay, so these are the IPs. You can actually, depending on this calculation, you give the IP, then this is the configuration of router 1, This is the configuration of router 2, this is the configuration of router 3, router 4 and router 5, and like that we complete this particular topology. This is the practical part of it. So